So one of the most basic measurements we're going to look at regarding speeds and feeds is our RPM, or revolutions per minute. Many of you may already be familiar with this measurement in relation to other motors or tools that you may have used, or whatever your background may be, but not everybody will be. So we're going to quickly cover what this is and how we can measure it. So the revolutions per minute is simply the number of times the tool will complete one entire revolution, so turn 360 degrees, in a given minute. Now at very low RPMs, such as we've got displayed here, we can count this. I've put a small orange mark on the tool, and we could sit here and count 1, 2, 3, 4, 5, 6, and time it with either a second hand on a watch or a stopwatch to determine how many revolutions per minute we're running. Now this only works at very low speeds, as we're showing here. If you're doing 60 revolutions per minute or 120, maybe upwards of 180 revolutions per minute, you'll be able to count this, but we aren't often going to be turning that slow on these smaller machines with our smaller cutters and smaller workpieces. We're usually going to be turning at higher RPMs than that. And as we increase the RPM, we quickly lose the ability to count those marks manually. They just become a blur. So we have to have another method of counting these. So the tool we're going to use to measure these is what's known as a tachometer. This is also sometimes referred to as simply a tach, and this will measure our RPMs. A lot of you may have already seen a tach, even if you're not familiar with them, in that a lot of vehicles have a tach on their dashboard next to the speedometer. There are several different types of tachs that we can purchase and use on the machine, and there are a few that we can't use on the machine. The lowest cost units you're going to find, which can be as little as $10 or under, will simply have two leads, and they're designed to be used on an engine that creates a spark. So it attaches to the spark plug itself, and it counts the number of times that spark plug fires, and that gives the RPMs of the engine through some other calculations, depending on whether it's a 2-stroke or 4-stroke, so on and so forth. We can't use those on this machine. Another type is what's referred to as a Hall sensor, and you will see these quite often, and they are used on a lot of machinery. The Hall sensors are often used in conjunction with a magnet. So the sensor is placed stationary, and then a magnet is attached to the spindle or the spinning piece. And these work fine. The drawback I see to them is having that magnet, and if you work on a lot of steels, you're going to obviously be collecting chips, depending on where the magnet is placed and how far away it is. Additionally, we have to attach that magnet to the machine somehow, and it becomes a potential that magnet, if not properly secured, can become a projectile and come flying off. So if you do use a Hall sensor with a magnet, make sure that you inset that magnet and secure it very well. I wouldn't rely on just a low strength adhesive, or an adhesive that's going to be affected by vibration over time. So be aware of that. Another type of sensor uses what's referred to as an interrupter wheel. An interrupter wheel is simply a round wheel, very similar to a gear, but instead of triangular notches as we have on a common gear, we have square notches. And the sensor is placed such that it can see where the notches exist on that wheel, and it counts those. These again work just fine. They're going to be quite accurate because they'll quite often have a large number of notches to count. But we have to mount that wheel, and that may be a little more difficult or inconvenient. And then the other common one is what I have an example of that's shown here, which uses optics and light. So this will count reflective surfaces or light and dark surfaces as they pass by the unit. This happens to be a handheld unit, and it doesn't work at very close distances, but this unit can be purchased for under $15 shipped, so it's a quite reasonable option. I believe, I'm not positive, but I believe that the Sureline DRO also uses an optical sensor. So the Sureline DRO, if you have that on your machine, it has the ability to display the RPMs. There are also options such as this. This is from Vista CNC. and they call this their iMach 3 spindle tack. And this is designed to connect to a computer and be used with software to display the readout on the computer or with the CNC software that you may be using. And this one is designed to mount fairly close to the reading surface. And then another one which I don't have, which I do plan to get in the future, is what's referred to as a tachulator. And the tachulator is a standalone unit. And the nice thing about it is it combines a tack and a calculator into one. So it will not only give you your RPM readout, but you can input in your cutter or your workpiece diameter, and it will actually calculate the SFM and display the SFM directly for you, saving you a step. At some point in the future, if I am able to purchase a tachulator, I will do a video review on that. So on the Shoreline, we have this great feature of having a continuously variable speed. So simply by turning a knob, we can increase or decrease the speed. We do have two pulleys. We have a high speed and a low speed groove on our pulley settings. And this continuously variable nature makes it very, very easy for us to quickly and rapidly adjust to different conditions and situations with our machines. This is a very, very convenient feature. You're starting to see it more on larger machines as well, but it can add several $100s to the cost on larger machines. It can almost add the cost of the entire Shoreline mill or lathe just to get that variable speed feature on larger machines. The traditional way that larger machines work is with a series of either gears or belts and pulleys and a fixed speed motor. So the motor runs at a specific RPM. We can't vary the RPM of the motor, but we can vary the speed of the spindle on the machine by changing and moving belts between different pulleys and different configurations. We have to turn the machine off, detension the belts, move them, retension the belts, turn the machine back on to make a change. So those changes obviously take considerable more time than what we can do with the simple knob here. The drawback, however, to the simple knob is we don't know what our numbers are, and that's where we have to use this tack. On those machines with fixed speed motors, we know if we put the belt in a specific position what our speed is going to be, whether it be 200 RPM or 600 RPM or 2000 RPM. But here we have to have a way of calculating it, and that's where these tachometers are going to come into play. Some machines have a built-in spindle tack on the speed control itself, or again, you may have added one. A lot of the optical units rely on a setup such as what I've got shown here, which is having a black surface. So I've painted both the vertical and the horizontal surfaces of my pulley and my spindle black using just a Sharpie. The darker it is and the more matte it is, the better. Since we have a reflective surface by default, that becomes a little bit of a problem. And then most of these units will come with reflective tape, or they'll come with a patterned wheel that has alternating white and black sections that you can then attach to the machine. So this particular handheld unit has a little light indicator as well to see where we're reading the surface from. The light from these units can either be visible, they can rely on ambient light, or they can use infrared or laser sensors to help create reflected light. So often you'll want to hold these in a 90-degree angle to the surface that's being read. They do work well on round as well as flat surfaces. A lot of these units do not work very well at very low RPMs, but honestly, we're not going to be using those low RPMs on our Shoreline machines because we're not going to have the need to turn a large cutter or a large diameter workpiece that requires those much slower RPMs. To check that our meter is working, we can turn our machine all the way up and take a reading. Now the max spindle speed of the Shoreline lathe and mill with the default pulleys that come with it is stated as 2,800 RPMs. I'm getting between 2,800 and 11 and 12, so I'm a few RPMs faster than what's stated by the factory, whether that's the meter or whether I just happen to have a motor that will run ever so slightly faster. That's within tolerance. So that's a good way to check that you're holding the meter in the right position and that you can get a good quality reading with the particular meter that you have. Now there is an optical gauge that relies on your eyes and the frequency of flashes that come from the lights in your room. In North America, this is 60 hertz, so that means that the lights strobe 60 times every second. And we can use a gauge like this, and this is a free gauge. You can simply search for Shoreline RPM gauge and download this as a PDF from their website, and it states that you can cut it out, glue it to the pulley, and to use it under fluorescent lights for the best results. So I've mounted this printed out on there just temporarily, and I'm not having any luck with it, to be perfectly honest with you, whether visually or with a camera. I've tried it under different light sources. I've got an overhead fluorescent, and then I actually use fluorescent photography lights, and I've got some LED lights mounted, and I can't get this to work with any of those or any combination of those. So I'm unsure why I cannot get this to work. So I hope you do have better luck with this than I have had. So I've tried everything I can think of with this paper gauge, and I cannot get it to work. I'm sure it's something obvious that I'm doing wrong here, or maybe it is purely my light setup. But I've tried repositioning it and making sure it's as centered as closely as I can. I have used these in the past on a drill press to check a drill press's speed, and they've worked fine for me in the past. I've gone down to a single fluorescent light. I've tried various fluorescent light fixtures, and I can't get this to work. What should happen is as this spins, one of the ring of lines that the mill or lathe is running at should appear to stop. So you should see the black and white bars quite clearly. They may move slightly. They may look like they're rotating a little bit, which means you're off a little bit on speed. If you're dead on speed, it'll appear that one of the rings has stopped moving entirely. Again, I don't know why this isn't working for me. Hopefully you have better luck if you choose this method. Otherwise, I would recommend either a handheld unit, as we've demonstrated, or a permanently mounted unit, whether that be connected to a computer or whether it be a simple straightforward unit, which usually runs $80, $90, or if you go for something along the lines of the Tachulator, which is my plan, which runs a little bit more expensive at $110, but it does do that SFM calculation for you. And we'll get into SFM next. I do hope you've enjoyed this video. Feel free to leave comments. Maybe some of you have used this gauge and it works fine for you under your lighting conditions. Or maybe you can point out what it is that I'm doing wrong. If you see that I'm doing something wrong here regarding this gauge. And if you like the video, give it a thumbs up. And as always, to see additional videos in the future, be sure and subscribe.